morning, math learners! It's nice to see you again. I am Ma'am Kislin A. Vicencio, your virtual math teacher for the day. Come and join me for another fun learning experience in Mathematics 8, only here at Valenzuela Live. We are now on Quarter 4, Week 3, wherein we will discuss proving inequality in a triangle. Allow me to present to you our learning competencies for today. At the end of the discussion, you should be able to prove inequalities in a triangle. Just a few reminders before we start. Please make sure you have your module in mathematics. Also, make sure that you have your pen and paper with you for solving and taking down notes purposes. Today, we will have fun while learning the lesson in mathematics as we play one of the famous Android games entitled Among Us. There will be 10 players in the game with two different roles, the crewmate and the impostor. Let's see what our role will be. Nice! We have designated a role as a crewmate. We must run around the ship and complete the tasks related to the lesson while trying to identify and avoid the two impostors. Our first task is entitled Crack the Code. In this task, we need to observe the given figure. Then, we will determine the relationship of the measure of their sides or angles. We will choose the letter that corresponds to our answer. Afterward, we will use this letter to crack the code. We are only given 5 seconds to key in our answer in the comment section. Are we all set? That's great. Let's start. Here is our first figure. How will you describe the measure of angle A and the measure of angle B? Is it letter L, equal, letter P, less than, or letter S, greater than? 5 seconds, begin. If you type P, that is a good start. Angle A is the opposite angle of side BC, which measures 6, while angle B is the opposite angle of side AC, which measures 7. The measure of side BC is less than the measure of side AC. Thus, the measure of angle A is also less than the measure of angle B, because according to triangle inequality theorem number 1, or the side angle inequality theorem, if one side of a triangle is longer than the second side, then the angle opposite the first side is larger than the angle opposite the second side. For our second figure, how will you describe the measure of side JL and side JK? Is it letter B, equal, letter E, less than, or letter L, greater than? You have 5 seconds to click your answer. Timer starts now. If you answered L, You are correct. Side JL is the opposite side of angle K, which measures 65 degrees, while side JK is the opposite of angle L, which measures 15 degrees. The measure of angle K is greater than the measure of angle L. Hence, the measure of side JL is also greater than the measure of side JK. Because, according to triangle inequality theorem number 2, or the angle side inequality theorem, if one angle of a triangle is larger than a second angle, then the side opposite the first angle is longer than the side opposite the second angle. Here is the third figure. How will you describe the measure of angle ARE and angle CAR? Is it letter A, equal, letter D, less than, or letter I, greater than? Key in your answer, go! If you type I, you are amazing. Angle ARE is the exterior angle of triangle CAR, and angle CAR is the remote interior angle of triangle CAR. Therefore, angle ARE is greater than angle CAR because, based on the exterior angle inequality theorem, the measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. Let's have the next one. How will you describe the measure of side RA and side AN? Is it letter D, equal, letter E, less than, or letter N, greater than? 5 seconds, go! If you answered E, you are excellent. The measure of angle ROA is 35 degrees, and the measure of angle AON is 45 degrees. Since the measure of angle ROA is less than the measure of angle AON, we can conclude that the measure of side RA is also less than the measure of side AN because of the hinge theorem. It states that if the two triangles have two sets of congruent sides, the larger included angle will have the longer third side. For our fifth figure, how will you describe the measure of angle 1 and angle 2? Is it letter D, equal, letter R, less than, or letter S, greater than? Our 5 seconds starts now. If you type R, you are great. The measure of opposite side of angle 1 is 10, and the measure of opposite side of angle 2 is 12. Thus, we can conclude that the measure of angle 1 is less than the measure of angle 2 because of the converse of hinge theorem. It states that if two triangles have two sets of congruent sides, then one with the longer third side has the larger included angle. For our last figure, how will you describe the measure of side EN and side NI? Is it equal, less than, or greater than? Your timer starts now. If you answered S, you are awesome. Side EN and side NI has the same tick mark. Tick marks are used to show which sides are congruent. Hence, the measure of side EN is equal to the measure of side NI. Great! It seems that you still remember the theorems about triangle inequalities. So, what is the code in our first task? Very good! It is flyers. Do you know that flyers are one of the applications of the hinge theorem? Flyers, scissors, and many other tools are hinged because when the angle between the blades of a pair of pliers increases, the distance between the tips of the blades also increases. Good job, math learners! We are able to finish our first task. Now, we can identify who is the impostor among us. You may type your answer in the comment section. All of you answered white. Let's see if white is the impostor. Yay! We eliminate the first impostor. There is one more impostor left. From the previous lessons, it was discussed how to prove congruency in triangles, how to use two-column proof, which provides an inferential argument, and from there, logical deductions are made through the set of presented facts, theorems, and axioms. Now, in proving inequalities in triangles, the same process goes in proving triangle congruency to finally prove the propositions at hand. Let us recall the theorems about triangle inequalities. First is the exterior angle theorem. It states that the measure of an exterior angle of a triangle is equal to the sum of the measure of its two remote interior angles. Second is the exterior angle inequality theorem. It states that the measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. We also have the triangle inequality theorem number 1, or side angle inequality theorem. If one side of a triangle is longer than the second side, the angle opposite the first side is larger than the angle opposite the second side. For the fourth theorem is the triangle inequality theorem number 2, or the angle side inequality theorem. It states that if one angle of a triangle is larger than the second angle, then the side opposite the first angle is longer than the side opposite the second angle. The next one is triangle inequality theorem number 3, which states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. We also have the hinge theorem, or also called as SAS inequality theorem. This theorem states that if two triangles have two sets of congruent sides, the larger included angle will have the longer side. Lastly, is the converse of hinge theorem, or the SSS inequality theorem. It states that if two triangles have two sets of congruent sides, then the one with the longer third side has the larger included angle. Aside from this, there are other definitions, properties, and theorems that can be used to prove other geometric statements in triangle inequality. We will recall them as we go along in our discussion. Let us start with our example number 1, which is about the proof of exterior angle inequality theorem. Given this figure, angle L and angle O are two remote interior angles. Let's prove that the measure of angle OBE is greater than the measure of angle L, and also the measure of angle OBE is greater than the measure of angle O. We will use two-column proof. Our first statement is angle L and angle O are two remote interior angles, as the given. Second, we can say that angle OBE is an exterior angle by the definition of exterior angle. From this, we can say that the measure of angle OBE is equal to the measure of angle L plus the measure of angle O because of the exterior angle theorem. Therefore, the measure of angle OBE is greater than the measure of angle L, and measure of angle OBE is also greater than the measure of angle O. And the reason is the whole is greater than any of its part, or also known as the whole part postulate. Let's have the next one. From the given figure below, prove that the measure of angle 1 is greater than the measure of angle 3. Based on the figure, we can state that angle 3 is the remote interior angle of triangle ABC. Angle 2 is the exterior angle of triangle ABC, and remote interior angle of triangle BCD. Angle 1 is the exterior angle of triangle BCD, and the reason is given. Since angle 1 is the exterior angle of triangle BCD, and angle 2 is the remote interior angle of triangle BCD, we can say that the measure of angle 1 is greater than the measure of angle 2 because of the exterior angle inequality theorem. In triangle ABC, angle 2 is the exterior angle, and angle 3 is the remote interior angle. With this, we can say that the measure of angle 2 is greater than the measure of angle 3 because of the exterior angle inequality theorem. Using statements number 2 and number 3, we can say that the measure of angle 1 is greater than the measure of angle 3 because of transitive property of inequality. For example, number 3, using the hinge theorem, we will complete the given statement using the symbols greater than, less than, or equal, and give an explanation. For our first given, side KD is blank to side DN. From the given figure, side KI is congruent to side NI. The reason for this one is given. We can also say that side ID is congruent to side ID by reflexive property of congruence. The measure of angle KID is 45 degrees, and the measure of angle DIN is 60 degrees. Hence, we can say that the measure of angle KID is less than the measure of angle DIN, and the reason is given. Therefore, we can conclude that the measure of side KD is less than the measure of side DN by Hinge theorem. So, the answer to complete the statement is less than. For our second given, the measure of angle ETM is blank to the measure of angle ITM. From the given figure, side ET is congruent to side IT as the given. Also, side TM is congruent to side TM by reflexive property of congruence. The measure of side EM is 50 cm, and the measure of side MI is 42 cm. With this, the measure of side EM is greater than the measure of side MI, and the reason is given. Using these statements, we can conclude that the measure of angle ETM is greater than the measure of angle ITM because of the converse of the Hinge theorem. So, the answer to complete the statement is greater than. For number 4, as illustrated in this figure, given side AC is congruent to side AR, and the measure of side CE is greater than the measure of side ER, we will prove that the measure of angle CAE is greater than the measure of angle RAE. The first statement is side AC is congruent to side AR as our given. We can also say that side AE is congruent to side AE by reflexive property of congruence. Next, we can state that the measure of side CE is greater than the measure of side ER. It is also a given. With this, we can conclude that the measure of angle CAE is greater than the measure of angle RAE by the converse of Hinge theorem. For our fifth example, the given is side WL is congruent to side SL. We will prove that the measure of side WY is greater than the measure of side SY. Side WL is congruent to side SL as our first statement. The reason for this is given. Side LY is congruent to side LY by reflexive property of congruence. Analyzing the figure, we can state that the measure of angle WLY is equal to the sum of the measure of angle WLS and angle SLY by angle addition postulate. With this, the measure of angle WLY is greater than the measure of angle SLY because the whole is greater than any of its part, or the whole part postulate. Therefore, the measure of side WY is greater than the measure of side SY by Hind's theorem. Let's have the last example. As illustrated by the figure, given angle 2 is congruent to angle 1, prove that the measure of angle 3 is greater than the measure of angle 1. The first statement is angle 2 is congruent to angle 1 as the given. Since angle 2 is congruent to angle 1, we can say that the measure of angle 2 is equal to the measure of angle 1 by definition of congruent angles. We can also state that the measure of angle 3 is greater than the measure of angle 2 by exterior angle inequality theorem. Hence, using statement number 2 and 3, we can conclude that the measure of angle 3 is greater than the measure of angle 1 by substitution property of inequality. After understanding the concept of proving inequality in a triangle, I think you are ready for our second task. This task is entitled, Just Give Me a Reason. Our goal is to complete the two-column proof table by choosing the correct reasons. We will click the reaction button that corresponds to our answer. We are given 10 seconds to key in our answer in the comment section. Each time we complete the table, we can refill the fuel tank of our ship. Are you ready? Let's begin. For our first question, given angle OLE is congruent to angle LOE, prove that the measure of angle OEB is greater than the measure of angle LOE. Statement number 1 is from our given information. For what reason is the measure of angle OLE is equal to the measure of angle LOE? Is it like vertical angle theorem or hard for the definition of congruent angles? The timer starts now. If you drop heart, then you are fantastic. For statement number 3, the measure of angle OEB is greater than the measure of angle OLE. What should be the correct reason? If your answer is exterior angle inequality theorem, choose like. If it is Hind's theorem, choose heart. 10 seconds, go. If you click like, then you are awesome. We can now refill 1/3 of our fuel. For our second question, given side LB is congruent to side LC and the measure of side BK is greater than the measure of side CK, prove that the measure of angle BLK is greater than the measure of angle CLK. Again, statement number 1 and 3 are from our given information. For what reason is the side LK is congruent to side LK? Is it like definition of midpoint? Or heart, reflexive property of congruence? The timer starts now. If you hit heart, then you are right. For the fourth statement, the measure of angle BLK is greater than the measure of CLK. What will be its reason? Will you choose like, hinge theorem, or heart, converse of hinge theorem? 10 seconds, begin. If you drop heart, then you are tremendous. We can now refill our fuel again. Great! We are almost done with our second task. Let us have one more. For our last question, given side OC is congruent to side NC, prove that the sum of the measure of side NI and side IC is greater than the measure of side OC. Statement number 1 is from our given information. For what reason is the measure of side OC equals to the measure of side NC? Is it like a reflexive property of congruence, or heart, definition of congruent segments? Key in your answers, go! If you click heart, then you are correct. For our third statement, what will be the reason for the statement the sum of side NI and side IC is greater than the side NC? Will you choose like triangle inequality theorem, or heart, hinge theorem? 10 seconds starts now. Time is up. If you hit like, then you are brilliant. Good job, math learners. We can now complete the second task. Since we are able to complete all the tasks, the last impostor will be eliminated. Let's see who the impostor is. Congratulations! You did great, math learners! You were able to win the game and master the lesson about proving inequality in a triangle. To sum up today's lesson about proving inequality in a triangle, here are some things to keep in mind. First, number each step. Second, start with the given information. Third, statement with the same reason can be combined into one step. Fourth, draw a picture and mark it with the given information. Fifth, you must have a reason for every statement. Sixth, the order of the statements in the proof is not always fixed, but make sure the order makes logical sense. Lastly, reasons will be definitions, postulates, properties, and previously proven theorems. We will now answer some questions coming from our FB Live viewers. You may type your question in the comment section. Here is a question coming from our random viewer. Ma'am, what is the difference between hinge theorem and SAS congruence postulate? That is an interesting question. The hinge theorem is also known as the SAS inequality theorem. It is different from SAS congruence postulate because hinge theorem used in proving inequalities of two triangles, while SAS congruence postulate is used in proving congruence of two triangles. Here is another question. What is the difference between exterior angle theorem and exterior angle inequality theorem? The answer is the exterior angle theorem states that the exterior angle is equal to the sum of the measure of the two remote interior angles, while the exterior angle inequality theorem states that the measure of an exterior angle is greater than the measure of either of its corresponding remote interior angles. For other queries or clarifications, you may raise them to your math teacher. They will be more than happy to assist you during your follow-up discussion. For your home learning tasks, answer the following activity. You may take some screenshots of it. I hope you learned a lot. Thank you again for joining today's class. This has been Ma'am Kaislyn. See you again next time for another episode of Virtual Mathematics class. Only here at Valenzuela Live, where learning together is never a hindrance even though we are apart. Stay home, stay safe, and may God bless you today and always. Bye!